Welcome to today's video. This will continue our introduction to JavaScript, and we're going to pick up right where we left off from the last video. So we wrapped up talking about functions and how do we work with functions, and now we're going to talk a little bit about, real quickly anyway, talking about how we include external JavaScript files, and then we'll move back into more talk about events, some of the events and how we work with events, arrays, and some of the other basic control structures. So by and large, there's definitely some new content here if you've never worked with JavaScript, but a good chunk of this should also be reviewed. So with that, how do you link to external JavaScript files? These are important. It's an important process because, as I mentioned in the last video, we oftentimes will organize our code in a way in those external files, then we'll load them or link them only when we need them in a page or a specific set of pages. An example of doing that, we still use the script tag. The only thing that we define is then we do define the source attribute. So we say source equals and then the URL or the link or the location of that external JavaScript file. You can have the type attribute, we discussed that in the last video, but it's optional. You don't need it because browsers assume that when you use a script tag that it's going to be JavaScript. I've modified or added this to this file here, a basic JavaScript file, and here's an example of doing that. And so this website, this page would run, and it'll look for, in the same directory that it's running out of, the same directory that it's been requested out of, a file named external.javascript. When this file is included, then it executes any code inside of there that's going to be executed, or defines all the functions that are in there as well. And so let's say that you have in external.js, you have a function. You can't call that function in that file, in your code until you've included it. And so you'll oftentimes see some of these scripts being included in the head section before any of that code is called. Right? So that's just an example of that. Again, it gets a little bit more to it than just simply including a file. How do we structure those and how do they work exactly? And we may or may not be able to get around to that just due to the amount of stuff that we're going to cover in the course. So definitely, as you start to write, if you go down that path and you start to write more web applications, you'll deal a lot more with external JavaScript files. Okay, commenting code in JavaScript is relatively straightforward. There's two primary methods. There's the line level comment, which is just 2 forward slashes, and then there's the block level comment that allows us to comment out multiple lines of code. You've already seen me use the line level, right? So we have 2 forward slashes that comments out that line, but the next line doesn't do anything too. If I want to do a block level, then you can simply do a forward slash and an asterisk, and then an asterisk and a forward slash, and that comments out that entire block from this character set to this character. Okay, so 2 primary ways in which we add comments to our code. Debugging is an important process with any program, with any application developer, with development in general. And what we're doing when we're debugging is trying to figure out what's going on in our code, what's going on in our program, and particularly when it's not working the way that we expect it to. There are 3 primary types of errors that you deal with. They're load time, runtime, and logical. Load time just means that something didn't load correctly. Runtime means generally means, or more commonly means, that the interpreters run into a syntax error. So you forgot a semicolon, or you didn't type the word var right, or you called a function that you haven't defined, or just some sort of a syntax error. Logical errors are oftentimes much trickier to track down because logical errors mean that there are no syntax, but your program isn't running the way that you expect it. There's an error in your logic. You wrote your condition wrong, or your loop isn't iterating the appropriate number of times, or you've messed up the math in some algorithm that you've generated, right? And so those are a little bit harder to track. And so what we oftentimes have to do is go through a process of debugging our applications. Now, there are much more advanced ways to debug our applications than what we're going to talk about. The basic way that most developers do it, at least when we're getting started, is really console.log. Right? We have a value, we have something that we're trying to debug, it's in our function, it's somewhere in our code, and we're logging the output, we're logging the value of variables, right? Or the value of a function. We're doing something and we're logging it to that console in order to help us understand what's going on in our application. Some developers you'll see will use alerts. I would encourage you not to use those just because they're kind of old and they're really annoying. But alert boxes and do something like this. Well, how do I know my function returns something's getting called? Well, if it gets called, an alert box will pop up. And in this case, we have to go back and comment this out. And alert boxes, you don't see them very often anymore in any sort of development environment or even on a production server or a website, but you'll see a box like this, and you have to click it to dismiss it in order to get your browser back or your page to continue to load. Right, so those are one way. Again, there are more advanced ways of doing this, and so we're just going to cover the basics because we just simply don't have time to go into some of the more or the finer details of debugging. Very similar process to any other programming that you've done, right? Syntax and logical. Okay, this may be then where JavaScript starts to deviate from some of your past experience. The web is event-driven, and JavaScript then is used or leveraged to be a part of that event-driven model. We'll talk more about that. We're going to introduce it here. We'll talk a little bit more about that with the DOM, and then as we begin or continue to develop applications. But events are just simply things that occur when a web browser or a web document is being loaded. The page is loaded, a button is clicked, the user hovers your menu item, the user submits a form, right? These are all events. And when those events happen, then we can write code to capture that event and do something. The user submits a form. We write code to validate their input. The user hovers over a menu. We write code to make the drop-down menu appear. And so we have the event itself as well as the event handler. And the event handler then is the code that we write to tell. It's the code that is run in response to that event, right? This is the code that we want to run when this thing happens. And so a very easy example or a very common example here to get started off with is to look at this input type. So input type is an HTML element that we can use for input. And we define the type attribute, and that tells the browser what type of input element it is. Buttons, radio buttons, checkboxes, some of those common things that you deal with when you're entering information on a web page. So in this case, it's a button. The value attribute defines the text of that button, and then we have the on-click event. So we say that for the on-click event, so when the user clicks this button, the event handler is a function called calc total. And so we can write a little example here. I can say function. We'll just call it click me, and I'll just simply have this thing log to console.log. The button was clicked. Okay. And now inside of here, we'll add an input type. So we'll say input type equals button, value equals test button. So that's the text that's going to show up on that button. And then the on-click event will call the click me function. Okay. Assuming hopefully I don't have any syntax errors. We refresh this page. We see a button, and now every time we click, we get output to console.log. Right? You'll notice though, it's not continuing to run. I get a little counter over here. And so when console sees that it's the exact same output being logged multiple times, it doesn't display each of an individual occurrence. It just starts to group them together and gives you this little counter. So every time I click, you see this number increases. All right, so that's the on-click event. There are a lot of events that we can deal with in an application. On-click is not limited to just a button. You can declare an on-click event in just about any type of element that you want. So let's say that we have a paragraph. We can say on-click equals click me, and inside of here we'll say test click event for paragraph. There we go. Oops, there we go. All right, so we can see if that works as well. Refresh our page. We got a paragraph here. And you see we click on it, and it's logging to console.log. Right, so a lot of elements will support a lot of these different events. You simply have to take that element and then add that attribute. What is the event, and what code do you want to have handle that event? Right, so here's the event. This is our event handler. A lot of events, right? And so we've included some links to this documentation, to event handlers to read in the course material. So you need to take some time and read that and understand all these different events, because there are a lot. This is not an exhaustive list. This is just a small sample to give you an idea. You know, if you think about it, there's a lot of events that occur that you wouldn't necessarily be obvious that a browser does. like the DOM is done loaded, the browser is done loading the page. That might not be obvious. We'll talk more about that with the DOM. Some of them are very obvious. On click, clicking putting your cursor inside of a text box, clicking on a button, hovering over something, scrolling something down. And so some of them are. And so it takes some time to get used to that. And the best place to get started is to go through a list like these and understand all the events that are available. On load, on unload, right? On load means the page is finished loading. We can do something. On unload means that the user is trying to navigate away. Have you ever had a site or a page tell you when you went to close that tab or close your browser, say, are you sure you want to leave? Well, that's because they have code that's handling the on-unload event. On focus, on blur, on change. Some of these aren't as obvious. On focus, that means that the user has selected or put their cursor inside of an input box. They've focused on that input box. On blur means that they have exited that box. And so you have events, you can write code to capture the fact that they clicked in the box and they clicked out of the box. Right? And why would you want to do that? Well, the on focus, maybe not so much, but the on blur, you might want to provide input validation the second they move out of that input box to provide them immediate feedback. And so this becomes a nice event to handle that code, to write code to handle that event. Right? So a lot of events, and you have to spend some time understanding these. Okay, this should largely be a review, working with operators and operands, right? We have basic assignment, we have, summation or addition, two expressions and assigns the value to a variable. This subtracts, this multiplies, this does modulus. These are examples and equivalent statements. And so this is the most verbose, and these are ways of creating kind of a short, or this is an example of doing that. And so x equals y, x plus equals y is the same thing as saying x equals x plus y. And so forth, right? So most of these are going to be mathematical then. Right? With this one, though, you can have string concatenation based off of the type of the operand, right? The type of the operators that are, whether they're string or they're numeric. Because we deal with, and we'll look at more examples down the road. So this is just to introduce this concept, because we may have to deal with, and we oftentimes will have to deal with taking input values. And input values from a text box are going to be treated as string values. We may have to convert things to make sure that they are mathematical, that they are numerical. And so you can have different types returned. If you try to convert a number that cannot be converted to a number, convert a string that cannot be converted to a number, you might get this result, not a number, NaN, right? So if you see this output in any of your variables, you're starting, your program isn't working the way you think it should, and you start doing some debugging and you start seeing this show up, it's because you're trying to convert something that cannot be converted. JavaScript cannot understand how to make it a numeric value, right? So look at some of the conversions that you're doing. You cannot divide a number by 0, and that's true pretty much across the board, and so you'll see an error there. You have functions. Is not a number. You can check a value that you want to convert to see if it returns whether or not, or tests whether or not a value is numeric or not. Is finite, right? That checks the value for infinity, right? If you can divide a number by 0 and it returns infinity, you might want to check for that. And so these are some things we can do in order to prevent errors from being introduced into our code, because we have a broader range of possible values coming in, especially from any sort of an application that takes a lot of user supplied input, because we don't always know what the users are going to put into our applications. We have to be very, very careful, and we have to check. Right? We have to check a value. If we expect it to be numeric, we want to make sure that we check that it is numeric, that we can convert it to numeric before we actually try to convert it to numeric, because we don't want to generate any errors, or we want to minimize the number of errors that we do generate. Again, largely review here, comparison operators. If we want to create a condition, whether it's for a loop, for loop, or a while loop, or an if statement, we have comparison operators: equal, not equal, greater than, less than, greater than, equal to, less than, equal to. The definition, here's an expression, and this is what it returns, right? So we compare two things together for equality, whether they're not equal. The purpose here is that we're going to get a true or a false value, and that we're using these to help make decisions in our program. Logical operators work much the same as they do in any other language that you've worked on them in. Logical and, logical or, logical negation, right? So and, or not. Logical and means that both conditions must be true. So if we say this expression, right, and we know that this expression will be true or false, and we use the logical and, then we're saying that this and this have to be true. This or this, right? When we use logical or, we're saying only one condition must be true. So we can say this or this needs to be true. If this is true, then we're fine. That's all we needed. If this is true, then that's all we needed. If both of these are false, then this overall statement isn't true. All right, that's kind of the opposite here. Oops. Kind of the opposite here. This has to be true, and this has to be true. If this is false, or this is false, or this is both false, then this overall evaluates the false. And the condition would not ultimately be true then. Logical negation just negates. So if x equals 20 returns true, then this negates that to be false. And you have to be kind of careful with logical negation because it can make it a little bit tricky to understand the logic that's being used in the program. And so, just use it sparingly. There's some really good examples, really good use cases. Typically, when you're dealing with functions that return Boolean or kind of is valid, right? You'll write a function that returns whether or not an input value is valid zip code. And when it's not valid, then you want to tell the user that it's not. And so there's a good example of taking a function that returns a Boolean and then negating it and then reacting off that negation, so that when it's not true, you can do something. You can prompt the user. I don't know. That probably would have been better served with an example, but I just don't have them out ready to go. Okay, arrays. Arrays are a very powerful common structure that we're going to work with throughout JavaScript, and we're going to see this more and more. We'll talk about it more with the DOM in the next lecture as well. So again, I'm assuming some familiarity with arrays, and so I just want to quickly talk through the concept of them, and then we'll look through some of the syntax with the sample files here. Variables can only hold one value, and so we're limited based off of that capability, and that oftentimes we want to be able to store multiple values in a single variable. If I need to work with 100 values because I have 100 grades and I'm writing an application that sums a grade or finds the average or calculates bowling scores or iterates through the number of tweets or something, I don't want to have 100 different variables. I can have one variable with 100 values, and that's where arrays are so important. We can index the elements of an array. So each individual value of an array is considered an element, and we access those elements by using an index. Okay, arrays start at index 0. Okay, so we have to say that the first element is at index 0, and it's a common mistake if you're new to working with arrays to take that index and forget that it's 0 based and say index 1 instead of index 0. We'll look at some examples. How do we create arrays? Okay, variable declaration. So just like we've been talking about with variables here, we use the var keyword and then the name of the variable. You have three different ways, a couple different ways here. You can say new array, and then this value could be the length of the array. So let's say that we want an array with 50 values, then we say new array with a value of 50 here. You can populate with a value, so you can say array at I, this is the notation to access an individual element, is equal to a value. Or you can declare and populate. So you can say var array equals new array with a list of values. And so how does that look? Well, we have some sample code here. Var my array. I don't think that was in my example, was it? No, it wasn't. I think I have. Oops, well, apologize. I thought I had that in the slides. Apparently I don't. There's a couple of different ways that we can define those. And so this would be similar to saying var my array equals new array, and then my array at 0 equals 1, my array at 1 equals 2, and so forth, right? And we just keep going. So we declare an array, and then we start assigning values to each individual element based off the index. Right? 0 based, so this 0 is our index, and this would give us the first element in the array. Right? If we look at this array, because this declaration I think is a little bit more concise, right? It makes it a lot easier because we can do this all with one line of code instead of multiple lines of code, which is what this method would have us do, or what we'd have to do to use that method. What we're doing then is we're defining an array with 1, 2, 3, 4, 5, 6, 7, 8, 9 elements. Okay. The first element would be at index 0, and so we use the name of the array, the square brackets, and then the index. Right? 0 is our first element, so that represents 1. Right? So if we load this page up in the browser, and we get rid of this, and we look at our inspect element, go to console, array value 1 at index, it's not at index 4, I'm sorry, it's at index 0. There we go, array value 1 at index 0. Okay, if we want to get 9, what do we need to do? It's the 9th element, it's at the 8th index. Right, so load page, array value 9 at index, oops, I gotta change that, at index 8. Because it's 0 based, 0 index, first element, index 1, the second element, and so forth, all the way to the end. Right, so our index, our last index value that we can use in an array is always 1 less than the actual number of elements in the array. This has 9 elements, but since we start the index at 0, the last index to get to the last element would be 8. Okay, so that's kind of the basics behind the array. Here's some more examples, and so sample code uploaded for you to look at and to review. Hopefully a lot of this makes sense. My array, okay, very similar here. We declare this array. If we want to access an individual element, just like we did up here, we can access that element. That element then, when we reference a particular element in an array, it's kind of like treating it like a variable. If we want to assign it a new value, we can do that. We can just say this element has a new value. Right? And so the array at element 5, right? So 0, 1, 2, 3, 4, 5. Once this is done, and we can do console.log to see that, it'll have a value of 99 instead of 5. Which is this value right here. Okay. With JavaScript, arrays are objects. They have properties and some very, very valuable properties for us to work with. We can do array.length. That gives us the number of elements in our array. You can, when you want to add additional elements to array, you just simply have to add them to the array, which is pretty nice. It makes it pretty easy. So we have what did we say? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We had 11 elements here. If we want to add another element, we just say my array at position 11 equals a new value, whatever it is. Okay, we could say my array at position 200 equals a new value, or 20, let's just do that, equals a new value. It leaves the values, the elements in between those, empty, but we've just simply added a new element to this array. All right, so it's good and bad. It's pretty easy to add new elements, but it can also cause some issues. So that's pretty straightforward. If you want to shorten an array, you have to change the length property. So just like we can use that length property to get access to the number of elements, we can change it to shorten our array. And so if we have an array of 10 and we want to make it 5, we just say array.length equals 5. And that changes the length of the array. Okay, a lot of methods. And so again, this is just a snippet to give you some idea. Review the material as you work more with arrays. Look for functions. Go to JavaScript, go to the documentation that I've linked to, and study that and read that so you can understand what to do with that. If you're ever asked to reverse an array, there's a function that does that. And so it would probably be easier than trying to write your own code to do it, unless you come up with a way to do it more efficiently. Right? So reversing, pushing and popping, adding values, removing values, joining arrays, sorting, converting it to a string, all sorts of things. And these are properties or methods of that array object. Okay, so we can access those properties. Length is plus my array.length. Right? And if we do that and reload this page, we'll see that the length is 11. We have 11 elements in this array. Okay, what happens if I do my array at 200 equals 100? Right? Let's see what that does to the length. Length is 201. Right? So just like we talked about. If we want to shorten this, my array dot length equals 5. Okay, and that changes the length of our array to 5. Okay, so very handy properties, very handy methods that we can call on that, making our work with arrays very easy. Okay, program loops, very common to use for and while loops in all programming languages, and so JavaScript is no different in that context. The syntax might be a little different, but it doesn't typically deviate too much from most languages that you work with. For for loops, you have the for keyword, so we say for, and then we have our counter variable, we have our continuation test, and then we have our update, or what do we change that variable so that we get this to eventually be false. Right? Our loop starts at true, and in order for us to break the loop, eventually this condition needs to be false. If we don't break that condition, then we've entered an infinite loop, and that oftentimes is not something that we want to do. We put our statements, our code, in between these curly brackets, and then this loop executes based off of these values, the number of iterations that it determines. While loops have a very similar syntax. We use the while loop, a very similar purpose. We have the while keyword, we have the parentheses, and inside of here is our continuation test. So as long as this is true, then we continue to loop. What makes this a little bit different is that we can, with a for loop, we define everything we need to determine the number of iterations in this part of the statement, in this part of the declaration. With a while loop, then we have to have the test, and we need to do something inside of this loop that eventually makes this false. Because if we don't, then we've entered into an infinite loop here. There is a do while loop. I don't use it very often. What changes is with a while loop, we test the condition before we iterate. And with a do while loop, you do an iteration and then you test. And so with a do while loop, you'll always get at least one iteration, where with a while loop, you may not get any. Same with a for loop. You may not get any iterations, depending on the conditions that you're using. Very common thing to do is to loop through an array. And so we can look at an example of doing that with this, let's see here, with this for loop right here. So we have our counter initialization and declaration, right? So this is a case in which single letter variable names is usually pretty appropriate. I, J, K, X, Y, Z. You'll see that very common with loops. We say I equals 0. So if we're going to iterate over the number of elements in an array, then we're going to use this not only to control our loop, but also as our index to access the indexes of the array. So we want to start at 0 because arrays start at 0. For the condition, this becomes a very good place to use that length property. So we say myArray.length. So as long as I is less than myArray.length, we'll get the number of iterations to get through every single element of the array. Right? If the array is 10, then that means I needs to be from 0 to 9. And this, because I is less than, let's say that this array is 10, I is less than 10, that'll give us values of I being from 0 to 9. This is how we control that variable, or the value that we assign to it. So in this case, we say I++, you could say I minus. This can be anything that you want as long as it results in an assignment, right? I could say I equals I plus 2 if I wanted to. Right? But in this case, because we're iterating over the contents of an array, we're going to go in by 1. Or by 1, sorry. Console.log, element at index I has a value of this. And so we'll use that variable then, and the value contained in that variable, to access each individual element through the index. Okay, so we'll save that and we'll run it, and there we go. Those are output. All right, so element at index 0 has the value 0, element at index 1, 2, 3, and 4, and so forth. Right, and that makes sense based off of we're using my array, and my array length is only 5. Of course, I can change that and run it, and we'll see what we get. And there we go. Right, 0 through 9, 10 elements, 0 through 9. This is 10 iterations. Okay, and we use the length property of that array to control that condition. Okay, we've already talked a little bit about conditionals, and so again, I don't have a whole lot to say about if statements. Again, I'm assuming that you've been exposed to those in your 150, at least in your 150 course. If statements are not much different in JavaScript. You have the if keyword, you have the parentheses, and then the condition. Condition can be anything. You can use a single condition, you can use multiple conditions with logical operators, as long as it can ultimately evaluate to true or false. When you put them together in a block, then these are all related. That is, that if this is true, we execute this code and then we're done. We're done with this block. If this is false, then we test the next condition. If this is true, we execute this code and then we're done. We don't continue to evaluate conditions or execute code. We continue to do that as long as these conditions are false. We evaluate the next condition, and if there's an else statement, then we execute this code here. Right? So if there's an if with a series of else if, all these conditions are false. If there's an else block, then we'll execute that code. Else blocks are optional. Else if are optional, and you can have as many as you want. Right? The only thing that you need for an if statement is an actual if statement. And so if you add else if and you want an else, the else is the last thing that you have. Else statements do not have a condition. Right? The only time you use a condition is if there's an if keyword in front of it. So the opening of this block, an if statement, or an else if. Okay, and we saw an example of that with this code here. So you can go back and take a look at that if you need a little bit of a refresher. Okay, switch statements, pretty similar again to other languages. You have the keyword switch, and then we have the expression. So this is the value that we're going to be matching against these case statements. All right, so switch, and then our expression, and the curly brackets. That's the overall outer structure. Inside here, then we have case and then the labels. And so these labels are what we're matching to this expression. So we say case label colon, and then in between this colon and this break keyword are the commands that we want to execute. It'd be kind of like having it in between curly brackets. Breaks are optional. And so if you don't include the break, it's not going to generate a syntax error, but what will happen is that your code will fall through. So if your expression matches on this first label and there's no break, your code will continue to execute until it hits a break or it simply hits the end of the switch statement. Okay, so the case labels match the expression. You can have as many case labels as you need. Make sure that you follow the syntax. You have the colons and you have a break with a semicolon. You can have a default case. And so you can say default, if nothing matches, it's kind of like an else branch in an if-else statement. The default branch then is just the default. If nothing matches, then do this code here. So we can take a quick look at that here, and I actually didn't intend to leave that code there. I'll leave it there, but I wasn't planning on talking about it. So we can say, let's switch off of a value of, we'll just use the first element of our array. Okay, and we'll say, let's say case 9 break and then just to speed things up, what is the first value? 0. So we'll say 0 break. Oops. Okay, and then the defaults. Okay, I'm going to comment out some of these other console.logs, and I'll go ahead and get rid of this one too. Save it, run the code, and see what happens. The value is 0. Which is what we expected. Okay, if I switch these around, so let's say that I make this be the top statement, and let's say that I take out that break keyword. What's going to happen? Execution is going to fall through. It's going to match on this label. It's going to execute this code. Because there's no break, it's just going to continue to execute until it encounters that break statement. And so we'll save that modification, and we'll run this code again, and you'll see value is 9, the value is 0. Right? Same thing's true if I forgot the case statement here. It would go all the way through to the end of the actual switch, and so we'd get output for all 3 cases there. 0, 9, and nothing matched. All right, so you have to be careful. There are cases, there are certain situations in which you may have a switch statement that you want it to fall through. But you do need to be aware that if you do not want them to fall through, you do need to use the break statement. Okay, let's see. Why did I have this code in here? drawing a blank. We have an array of Boolean values, true, true, false. And I think all I was doing is just using those values to control this loop. So we looked at a for loop right here. And with this one, we have a while loop. And what we're saying is that while bool's at this, so we're going to go through these values. While it's true, then we'll log that value and we'll increment our x counter. Okay? Because we're using x to access the elements of this array, it's kind of like we're doing this, it's very similar to this for statement, except that we're doing it with a while loop. So we have to declare that counter external, and we have to increment that counter inside of the loop itself. So it'll be true, and then false, right? That condition is tested after each iteration, right? So before we enter the loop and after each iteration. So first thing that we'll do is we'll look at bools at index 0, which is true, and we'll compare it equal to true. Because it's true, we'll enter the loop, we'll log the value of x, and then we'll increment x by 1. All right, we'll loop around. That gives us a value of 1, so we access the second element. It has a value of true. We log again, increment x by 1, loop around, test the condition. This is now false. This is no longer true. False is not equal to true. We don't iterate, and we're done executing. So we go beyond that script. So I'll save that. 0, 1, and then we're done. We got 2 iterations in that loop. Okay, because these values are true, true, and false, because they're Boolean, and all this needs is a Boolean. It just needs a true or a false. We don't have to have a condition. We can simply use the values returned from these elements in this array. And so if we take that comparison out, then run this code, you'll see that we'll get the exact same result. All right, so 0, 1. All right, so that was the purpose, I guess, of that little bit of code there. All right, well, that was about an hour's worth between the 2 videos of JavaScript. So hopefully that makes sense, and hopefully a good chunk of this was really review. Again, if I'm off on anything there, please let me know so that we can work together to figure out a way to fill in some of those gaps. Otherwise, if I don't hear from anyone, assume that we're moving along well, other than the fact that this is a 16-week course condensed into 6 weeks, and so it's going to be pretty intense. Have any questions or any comments, concerns, or anything else, please let me know. Otherwise, I'll see you in the next video. We'll talk about the DOM. Thanks.